we need to cover one section from chapter 20, which is about electrochemistry. And I'm sticking it in here because it relates to the oxidation-reduction business. This is a review of the oil rig and the oxidation-reduction stuff, because when I teach this section in Chem 1B, it's been months since we talked about it and they need the review. I'm not going to do that again because we just learned about it. It's fresh. When we balance these equations, the mass has to balance, meaning the number of calcium atoms or hydrogen atoms or whatever, but the charge also has to balance. Because we can't have something just gaining electrons or losing electrons without those electrons coming from or going somewhere. And so the method we're going to learn here is called the half reaction method of balancing redox reactions. We're going to break our equation into two half reactions, one for oxidation, one for reduction, balance those individually and add them back together. Yes?
Where are these slides at?
They are on the, hang on, I'll show you. So this is a list of instructions for the half reaction method of balancing aqueous redox reactions. The first step is, your book says, assign oxidation states and identify what's being oxidized and reduced. Okay, that's all very nice, but actually it's not absolutely necessary. So I'm just going to kind of skip over that. Kind of optional. We'll start with number 2. Separate the overall reaction into two half reactions. Then we're going to balance each half reaction in this order. First, we're going to balance with respect to mass. That's the elements. This is what we're familiar with. You're going to balance everything besides hydrogen and oxygen. Then you're going to balance the oxygen by adding water where needed, and you're going to balance the hydrogen by adding hydrogen's ions where needed. Then we're going to balance with respect to charge by throwing electrons in there. Then we're going to make sure that the number of electrons lost in the one reaction is equal to the number gained in the other reaction. We'll add them together. Electrons should cancel out, and other things might cancel out, and then we're going to double check that it's balanced. So here's our first example, and I've included a very brief version of the instructions. And again, I'm just going to skip this first one. Separate this into two half reactions. Okay, so here I have two reactants and I have two products. So hydrogen ion, I'm going to have that one be, and we want to line up our arrows here. So I've got hydrogen ion, and then I have to decide, well, is hydrogen ion going to change into hydrogen gas, or is it going to change into chromium? Yeah, hydrogen. And then the chromium. Well, the chromium metal is obviously going to change into the chromium ion, because you can't change chromium into hydrogen without nuclear chemistry. Okay, so that's step 1. Separate into two half reactions. Now we're going to balance them with respect to mass. This one is already balanced for mass, right? I've got one chromium and one chromium on each side. Up here I have one hydrogen, and over there I have two hydrogens. So if I put a 2 in front of the hydrogen ion, now that one's balanced for mass. So the next step is to balance with respect to charge. So I'm looking at the overall charge on the reactants. The overall charge on the reactants is +2. The overall charge on the products is 0. I have to make them the same. They don't necessarily both have to be 0, they just have to be the same. And the only thing I can do is add electrons. So if this is +2 over here, and I add 2 electrons to that side, I have +2 and -2, that adds up to 0, which matches the charge on the other side. And then down here, I've got 0 on the left and +2 on the right. So if I add 2 electrons over here, I've got +2 and -2, those add up to 0, and this is 0. Okay? That's what we mean by balancing with respect to charge. Now we need to make the number of electrons equal. Well, this one has 2 electrons and that one has 2 electrons. They are already equal. So we're good. So now we're going to add these 2 equations together. And we're going to cross out things that are the same on each side. Because what's happening here is the chromium is losing 2 electrons and the hydrogen is gaining those 2 electrons. And so we don't actually see electrons as reactants or products. They just got, changed, behind somebody's back or something. It happened, but it doesn't show up as a reactant or product. So the 2 electrons on each side should cancel out. That should happen every single time because we made them the same. And then we're going to copy down what's left. So 2 hydrogen ions plus a chromium atom is going to create hydrogen gas and a chromium ion. And then go through and make sure that the number of hydrogens and chromiums is equal and the total charge on each side is equal. Here, the total charge on the reactants is +2, and the total charge on the products is +2. Let's do another one. So again, we're going to start by breaking this into 2 half reactions. So I've got 2 reactants. I've got iron and I've got permanganate ion. Which one of these products is the most like Fe2+? Well, the Fe3+, right? So those guys are going to be in 1 half reaction together. So I got Fe2+. That's supposed to be a Q. I'm going to Fe3+. And then the other half reaction will be the other reactant and the other product. So MnO4 minus and Mn2+ aqueous. That first example, you could have balanced that one without using this method. But how would you balance this? There's oxygen on one side and there isn't any oxygen on the other side. You can't balance this one by inspection. Water. Yes, so this is an aqueous solution, meaning there's water everywhere. So the water sometimes gets involved in the reaction. Okay, so here's our 2 half reactions balanced with respect to mass. So we've got iron and iron. That's good. Here we have 1 manganese and 1 manganese. And then we leave the hydrogens and oxygens for last. So here I have 4 oxygens. So I need to add oxygen to this side. And we're going to do that by adding water molecules. So to get 4 oxygens, I'm going to need 4 water molecules. And I'm not just pulling water out of nowhere. This is all swimming in water. Yeah.
So we should add a water molecule to that side. It's going to hold on the hydrogen.
Well, now we created a problem with hydrogen.
So are we going to add the hydrogen to this side?
We're going to add hydrogen ions to the other side first. So you balance everything but hydrogen and oxygen, then you fix the oxygens, and then you balance the hydrogens using hydrogen ions.
So right now we're not touching the charges?
Correct.
We're just trying to balance the
We're not going to mess with the charges until we get all the atoms straightened out. Yeah. Mass first and then charge. So I have 4 oxygens and 4 oxygens, but I created a new problem because now I have 8 hydrogens over here and I have no hydrogens over there. Here we're balancing in an acidic solution, meaning there are hydrogens, ions floating around from the acid. So I need 8 hydrogen ions then, right? So that one was kind of a mess, but now it's all right number of hydrogen, oxygen, and manganese on each side. The next step is to fix the charges. So this top one, I've got +2 on one side and +3 on the other side, and I need to fix it so they're the same by adding electrons. So I need to add 1 electron over here because +3 and -1 adds up to +2. So the charges are the same. And then down here, on this side, I have a total of +2. And here I've got -1 and +8. So that's a total of +7. So here I'm going to be adding the electrons on this side. How many do I need? 5.
So that's a +8 right there on that.
So 8 hydrogen ions would have a +8 charge. And the permanganate ion is -1. And so then if I add the 5 plus 5 in here, 5, I'm sorry, not plus. This is, we're adding electrons, but it's negative charges. It's a -5 and a +8 and a -1. And so that adds up to +2. Yeah.
So the hydrogen is not a gas, right?
No, the hydrogen is not a gas. It's a hydrogen ion. You'll always be adding electrons on the product side for one and on the reactant side for the other. Because this is the oxidation, the loss of electrons, and this is the reduction, the gain of electrons. But we can balance it without recognizing which is the oxidation or reduction. But if you end up adding electrons to the same side for both of them, something went wrong. So don't go any farther. Just go back and figure out what the problem was. Next step is make sure that the number of electrons are equal. So this one's losing 1 electron, and this one is gaining 5. That's not going to work out. So I need this one to also be losing 5. So that means that this reaction has to happen 5 times. So I'll put coefficients in here of 5. So I'm going to have 5 iron 2s, making 5 iron 3s and 5 electrons. Okay? So now I can add these together. I've got 5 electrons on the left and 5 electrons on the right. This top half reaction is losing the 5 electrons. The bottom reaction is picking them up, so we don't see them in the reactants or products. And then I'm going to copy down the rest of the stuff. And just like adding, the order doesn't matter. Normally I keep them in the same order as they are up at the top, but I don't know why I didn't do that just now. So 5 Fe2+. And this is going to make Mn2+. Okay? Clear as mud, right?
I'll keep
Yeah.
you updated.
This is another one of those things that this is not a big deal. Stoichiometry, very big deal. Dimensional analysis, big deal. We're going to talk about gas laws on Thursday, big deal. Not a big deal, but for this class to transfer, you need to have learned about this, okay? So we're going to do our best for the exam on this chapter, and then we're not really going to do this again until there might be a question on the final, like 1, okay? I'm not going to do that one. So that's in an acidic solution. What if we're doing this in a basic solution? You're going to follow the same steps. There's just one extra thing that we're going to add in. So we balance for mass everything but hydrogen and oxygen. We balance the oxygen by adding water. We balance the hydrogens by adding hydrogen ions. But if this is a basic solution, there are hydroxide ions around, but there are not hydrogen ions. And so we're going to neutralize the hydrogen ions that we just stuck in there by adding an equal number of hydroxides on each side. Hydrogen plus hydroxide makes water. And so then we'll end up with it being balanced, but with OH minuses instead of H pluses. And couldn't we just do it with OH minus first without doing the H pluses? Give it a try. It's not easy. It's really messy. So just do it this way. Okay, so this is one where we're going to balance it in basic solution. So we're going to go through the same steps, split it into half reactions. So here I have I minus, and that is most closely related to I2 on the other side. So I'm going to have iodide ion on this side and iodine on that side. And then the other two, there's that permanganate again, and MnO2 over here. Two half reactions. Balance for mass. Oh, that's what happened. I thought my pen got fat. It did. Balance for mass. Okay, so one I and two I's. So I'll fix that by putting a 2 here. There's my regular pen back. So the top one's balanced for mass. The bottom one, I've got one manganese and one manganese. Okay, that's good. I have 2 oxygens and 4 oxygens. So I'm going to add water over here to get the extra 2 oxygens. So 2 plus 2, 4 oxygens and 4 oxygens. Now I have to balance the hydrogens, so I'm going to look at, I've got 4 hydrogens here, so I'm going to add 4 hydrogen ions over there so that my hydrogens are balanced. In a basic solution, we don't have hydrogen ions floating around, we have hydroxide ions. So this is balanced for mass. If I add the same number of hydroxide ions to each side, it'll still be balanced for mass. I have 4 hydrogen ions over here. I'm going to add 4 hydroxide ions. And over here, 4 hydroxide ions. If I add 4 hydroxides to 4 hydrogen ions, what do those do? They make water. So I'm just going to erase those. Eraser's too small. And that's 4 water molecules. Well, now we have 4 water molecules on one side and 2 water molecules on the other side. So we could like straighten that out a little bit, right? I could subtract 2 water molecules from both sides, and so that would leave me with 2 over here and none over there. Okay? Oops. Now I have to balance with the charges. So my top half reaction has -2 on the left side and 0 on the right. So if I add 2 electrons over here, that'll be balanced. Down here, I've got a total of -1 on the left side and -4 on the right side. So I need to add 3 electrons over there. Because -3 and -1 makes -4. Now we're going to add these together. But our electrons aren't going to cancel out, are they? This has 2 electrons and this has 3. We need them to be the same number. So we'll multiply the top one by 3 and the bottom one by 2. So this 3 times 2 will be 6, and this will be 3, and that'll be 6. And down here, 2 times 3, that'll be 6, and this will be 4, and 2, and 2, and 8. Now, my 6 electrons on the top and my 6 electrons on the bottom are going to cancel out like I need them to. I minus plus 4 H2O liquid plus 2 MnO4 minus aqueous to make 3 I2 aqueous plus 2 MnO2 aqueous plus 8 hydroxide. So there's a small subgroup of Chem 1A students that enjoy this.
I'm not one of them.
And sometimes see them on the board debating, no, it should be this, it should do that, and they get all into it because it's a puzzle, right? It's a puzzle. And most of the Chem 1A students are like, you guys are insane, right? No, their brains just work a different way. So balancing these redox reactions, if you don't learn how to do it, you'll lose a few points here and there, but you're not going to fail a class because of it. Yeah.
So the only difference between basic and acidic is instead of using hydrogen, you use oxygen?
Hydroxide. Yeah. Yeah, you're going to use hydroxide instead of hydrogen ions. And you can fix that here when you're balancing by mass, or if you got to the end and you're like, oh shoot, I forgot. That's supposed to be basic. You could fix it at the end too. Yeah. So I have more example videos that are available on Canvas, but I think you've had enough of this. Yeah?